the function h satisfies x squared minus 4 over 1 over 1 minus f of x cubed for x not equal to 2, which means that it's likely got a hole at x equals 2. It's also known that the limit of hx can be evaluated using L'Hopital's rule. Now, that's also a clue that we are dealing with a 0 over 0 situation. And it says, use the limit of x goes to 2 of h of x to find f of 2 and f prime of 2. So first of all, we need to understand the context of the problem. First, they're focusing on your understanding of continuity and differentiability. So that's going to be important to understand this issue of continuity here, and also understanding how L'Hopital's rule works. So this, first of all, we want to define this function. We want to have an idea what this h function is doing. Now, I've drawn here h as a piecewise function because it's going to be defined in two parts, when x is not equal to 2 and when x is equal to 2. So I've defined it in parts here. So I've just drawn in green a random function. We just know that's some random function, but it's defined at x equals 2. So it has a hole there. It has a limit. So there's a hole there. And it's defined at x equals 2. And it is differentiable. So this is important that we understand that this function is differentiable. Okay, because it's differentiable, it must be smooth and continuous through that point. So which means that if I were to draw in the second part of this, so this is a green graph, which is our h of x function described here. And the fact that it's smooth and continuous means that when I define x equals 2, it must fill in the hole to make it smooth and continuous. Okay, so that's important to understand. That means then that we can kind of visualize this function in this way. So we also need to be able to to actually answer the question here. It says, use h of x, limit as x goes to of h of x to find f of 2. So I'm going to do that first. I want to find f of 2. To do that, I need to be able to write an expression with f of 2. Okay, so that's going to be this expression here that is I'm going to start with. So I know that the x over 2 for 1 minus f of x cubed. Let me clean this up a bit. This is going to generate an f of x expression for me so that I can then evaluate f of 2. But I need to know what it's equal to. Now the fact that we can use L'Hopital's rule means that when we do the limit of this expression as x approaches 2, we should get a 0 over 0 expression. Okay, and that's true for the numerator. We can see if I plug in x is 2, I get 0 in the numerator. But what's also true is that for the denominator, we should be able to express this as well. So to express that, we should be able to say that 1 minus f of 2 cubed must be equal to 0. Okay, and we get that from this. We get that from the denominator of that limit because of the fact that if we can use L'Hopital's rule, it must meet this condition. And by meeting this condition, it allows us to generate an expression for f of 2. That's equal to 0, so it should say equal to 0. And then I can just solve for f of 2. So I end up with 1 is equal to f of 2 cubed, which then lets me define f of 2 is equal to 1. So there's the first part. F of 2 is equal to 1. I also need to solve for f prime of 2. To do that, I need to write an expression with f prime of 2. Okay, now to do that, we can generate f prime by differentiating this. And since we have the condition of 0 over 0, we can actually differentiate by applying L'Hopital's rule. So that's what I'm going to do then. So I'm going to have the limit as x is equal to, x goes to 2. I'm going to differentiate the numerator and differentiate the denominator. So it becomes 0 minus 3 f of x squared times, I have to apply the chain rule here, f prime of x. There's my f prime expression that I want. But I need to be able to solve this, I need this to equal something. I do know that my limit, when I apply my limit, because my limit from the left hand side and right hand side of this expression, as I approach 2, that limit is going to be equal to 4. And so I can make an equation equal to 4. And notice that, again, my numerator is equal to 4. That means then that my denominator must be equal to 1. So then I can equate this expression with that. Okay, so the numerator, when I evaluate, I get the 4 there. And so then I can write a separate equation here of 0 minus 3 of f of 2 squared times f prime at 2 must be equal to 1. And that comes from the denominator of that expression. So I've generated my f prime expression. I've made an equality to solve for this. So I do know I've already solved for f of 2 is equal to 1. So when I plug this in, I'm just going to write it over here, I end up with negative 3 f of 2 is equal to 1. So I'm going to plug in my 1 in here. 1 squared times f prime of 2 is equal to 1. I can solve for f prime of 2. F prime of 2 is equal to negative 1 over 3 when I solve that. So there is my f prime of 2. I've got f of 2. That's what the question is asking for. So again, it's important to recognize that this is, first of all, we have to understand this issue of continuity, be able to understand how these two bits of information fit together. Then I need to understand that I have to come up with an equation with f of 2, which is going to be this equation, and the equality is based on the condition of L'Hopital's rule. I also need to come up with an expression for f prime of 2. To do that, I need to actually apply L'Hopital's rule, and that will generate my f prime expression here. And then since the limit of as x goes to 2 of this expression must be equal to that value there because of the continuity of this, okay, so it has to be the dot that's filled in here, which is equal to 4. I can make that equality, and from that equality I can solve this equation for that one unknown part.